the spark. Why non-living matter suddenly woke up. You are made of the same atoms as a rock. The same hydrogen that fills your lungs existed at the moment of the Big Bang. Yet something happened. Something that transformed dead chemistry into consciousness, into you. So why didn't it happen to that rock sitting next to you? 4 billion years ago, Earth was hell. Molten, toxic, uninhabitable. And yet, life emerged. But here's the problem that haunted science for 2,000 years. If life only comes from life, how did the first life come into existence? This contradiction destroyed an entire worldview. For nearly 2 millennia, the greatest minds of civilization got it catastrophically wrong. Aristotle, perhaps history's most celebrated philosopher, was convinced he had the answer. Non-living matter, he claimed, could spontaneously generate life if it contained something he called pneuma, vital heat, a spark from the universe itself. He saw maggots crawling on rotting flesh and concluded, life springs from death. He watched microscopic organisms materialize in morning dew and thought he'd cracked the code of existence. 1,700 years of science accepted this as absolute truth. Kings and scholars built their understanding of biology on a foundation of pure speculation. Then in the 17th century, things got absurd. A scientist named Jan Baptista van Helmont was so convinced in spontaneous generation that he published instructions on how to manufacture mice. His recipe? Sweat and wheat grains. He believed he could engineer living creatures from human perspiration. The greatest minds were genuinely confident they could create life in a jar. And no one challenged them. Because without microscopes, without tools to peer into the microscopic realm, there was no way to disprove what you couldn't see, until one man decided to prove them all wrong. In the 19th century, Louis Pasteur conducted an experiment so elegant, so simple, that it demolished 2,000 years of false certainty. He filled a flask with nutrient-rich liquid. He sterilized it. He sealed it with a curved neck, a swan neck flask, that allowed air in but prevented microscopic particles from entering. Then he waited. Nothing. No life. No spontaneous generation. No miracle. As long as contamination from outside was blocked, life never emerged. Spontaneous generation was dead. But Pasteur's triumph created a crisis. If life cannot spontaneously arise from non-living matter, how does it exist at all? Earth's earliest days offer no comfort to those seeking simplicity. Picture the Hadean Eon. The planet is screaming. Volcanic eruptions consume the landscape. Radiation bathes the surface. Chemical chaos reigns. The very conditions that nurture life today would incinerate it instantly. And yet, in this apocalyptic hellscape, something shifted. Non-living matter somehow transcended into the living. The answer lies in understanding what separates a rock from a cell. 2 properties define life. The first is replication, the ability to copy yourself. Molecules that could duplicate themselves began to emerge in Earth's early oceans. The second is metabolism, the capacity to consume energy and use it. To grow, to move, to persist. These weren't properties of rocks. They were signatures of something fundamentally different. Carbon was the key. Unlike other elements, carbon is a romantic. It bonds with up to 4 other atoms simultaneously. This obsessive capacity for connection allows it to build chains, rings, lattices, structures of staggering complexity. The early oceans became a chemical symphony, billions of carbon-based molecules interacting, colliding, merging. Organic molecules everywhere. But they were still lifeless, still just chemistry. Then came the barrier, the membrane. Fatty acids began to arrange themselves in the ancient seas. These molecules had a split personality. One end craved water, the other despised it. In the ocean's embrace, they spontaneously curled into spheres, tiny bubbles, vesicles. Inside these molecular prisons, something extraordinary occurred. Chemical reactions that once diffused uselessly throughout the ocean became concentrated, amplified, efficient. These primitive bubbles were the first protocells, the threshold between chemistry and biology. But even inside these bubbles, the question remained: where does energy come from? The answer was waiting on the ocean floor, in the darkness where no sunlight could ever reach. Hydrothermal vents, cracks in the Earth's crust, superheated water rich with minerals and chemical compounds erupting from the planet's interior. These vents created gradients, chemical differences, like natural batteries, one side mineral-rich, the other depleted. This imbalance was precisely what early cells needed. They harvested this energy. They grew. They divided. And somewhere in this process, a new molecule emerged: RNA. It could store information like a library carved into chemistry itself. Over eons, this RNA evolved into something more stable, more elegant, more powerful: DNA. And with DNA came the ability to encode instructions, to pass information to offspring, to build bodies, to become complex. The first cells were impossibly simple by today's standards, yet infinitely more sophisticated than any molecule. They had crossed the threshold. They were alive. Everything alive today is descended from this moment. All life shares a common ancestor. Scientists call it LUCA, the last universal common ancestor. The bacterium and the whale, the fungus and the human, the blade of grass and your own body. You carry within your cells the same genetic code as a creature that lived 4 billion years ago in an ocean that no longer exists. Think about that. The carbon in your bones was forged in the heart of a dying star. The hydrogen in your cells was born at the moment of the Big Bang. You are made of stardust and primordial energy, rearranged into consciousness. The atoms that comprise you are older than the solar system, older than galaxies. They've existed since the universe itself ignited into being. We're accustomed to feeling separate from nature. We imagine ourselves apart, sophisticated, special, elevated beyond the rocks and soil. But the deepest truth biology can offer us reverses this assumption entirely. You are not separate from the universe. You are the universe observing itself. Matter that evolved the capacity to think, to question, to wonder about its own origin. The tiny chemical reactions that ignited in darkness on a hydrothermal vent 4 billion years ago never stopped. They continue right now. In your cells, in your neurons firing, in your consciousness forming these very thoughts. Life wasn't injected into matter from outside. It emerged from matter's own potential, from chemistry's hidden capacity to organize, to persist, to grow aware. We came from the stars. We came from the oceans. But most of all, we came from a universe that, given enough time and the right conditions, naturally evolves toward complexity, toward awareness, toward wonder. The question science spent 2,000 years chasing, how does dead matter become alive, was asking the wrong thing all along. The right question is simpler and far more profound. In a universe made of atoms, what's the difference between a rock and a mind? The answer might be that there is no difference. Only time, only possibility, only the universe expressing itself in infinite ways.